And we're back in Better Than Ever, still in 16.2, where we're discussing concentrations of solutions. In the last podcast, we introduced you to the idea of molarity as a way of expressing concentration. And so we were leaving off with example number 4, where we're looking to determine what volume of 2 molar calcium chloride contains 100 grams of calcium chloride. So it looks like you have a lot going on there, but the strategy is simply to set up your equation, to see what you know, look to see what you're trying to determine, and then move forward. So let's go ahead and get my pen back. There we go. We know that the molarity is going to equal the moles of solute per liter of solution. So let's plug in what we already know. We know that we have 2.0 molar solution. We know, we are looking for the volume. So we know that volume on the bottom is unknown. That's what we're trying to solve. So therefore, we must be able to know or figure out what the number of moles of solute is. Well, it doesn't tell us in the question how many moles we have. It tells us that we have 100 grams. So we can change grams into moles by using the molar mass. So 100 grams of calcium chloride. And if you use the molar mass, of course, you're going to have to take 1 calcium and 2 chlorines, add them up. The molar mass of calcium chloride is 111 grams per mole, or approximately. 111 grams per mole. Notice you got grams on the top, grams on the bottom. They divide out. So 100 divided by 111 is going to be 0.901 moles of calcium chloride. Okay? So we can plug that 0.901 moles of calcium chloride into our equation. And now solve for x. We're going to multiply x over to the other side, so that these x's divide out, top and bottom on this side. We can now divide by 2.0 molar. So these terms divide out with here and here. Now remember that molarity, capital M, really means moles over liters. So when you put moles on the bottom, that means that liters will go on top. The moles divide out, top and bottom. And now the only unit that you're left with is liters. So x will equal 0.901 liters over 2.0, and that's going to be 0.45 liters. Or if you want to change that into milliliters, you can move the decimal 3 spots to the right, or you can multiply by 1,000. So we have 450 milliliters. So this means that 450 milliliters of 2 molar calcium chloride will contain 100 grams of calcium chloride. So those are 4 examples that we have to show you different types of questions that we can ask regarding using that equation. Molarity equals moles over liters. Now in class, we'll be taking a look at making solutions of copper sulfate, so we'll do that pre-lab activity in class. Moving on to making dilutions. And let's go ahead and change colors just for the heck of it. Once you make a solution, when you dilute that solution to a new concentration, all you're doing is adding water. That is, the amount of solute does not change. We'll just say the number of moles of solute does not change. So therefore, if the number of moles of solute does not change, the moles of solute before you do the dilution will equal the moles of solute after you do the dilution. Now let's think about this, and you're never going to have to repeat this on a test, but let me show you why this equation that we're moving towards is going to work. So if, let's say you have the concentration before equaling the moles before And we're going to say that equal over the liters before. And we'll do the same thing. I'm just going to change up colors here. Let's do the same thing for after. We have the concentration after the dilution will equal the moles after dilution divided by the volume after the dilution. And if we rearrange these equations, let's go ahead and do that. We're going to multiply the liters before over to the other side. So multiply liters before, multiply by liters before. That means that these terms are going to divide out here and here. And if we do the same thing to the other equation, multiply by liters after and multiply by liters after, these terms, not that one, over here, these two will divide out. Therefore, what we're left with on this side, and I'm just going to change this just a little bit, I'm going to switch these around, the moles after is going to equal the concentration after times the volume in liters after. Similarly, if I rearrange the before, the moles before are going to equal the concentration before times the volume in liters before. Now, we originally said that the moles before equals the moles after. So we have moles before equaling moles after. Therefore, this term will have to equal this term. If this is the same as this, and this is the same as this, and this is the same as this, this must be the same as this. And so now I'm going to rewrite this equation to say that the concentration before times the volume before is going to equal the concentration after times the volume in liters after. Now, you actually don't have to use liters, and so since that is true, we're going to rewrite this equation as m1v1 over m2v2, where, if I just copy over this is the concentration before and the volume before, and that's going to equal the concentration after times the volume after. Alright? This is an equation that you'll be able to use for the test. And we have several sample questions here that we can walk through to show you the types of questions that we can ask doing a dilution question. Alright? In the next podcast, we'll tackle these samples. We'll see you next time.